Hello and welcome. Today, we're diving into a crucial aspect of modern software systems, building a real-time task management UI dashboard. This isn't just about pretty graphs, it's about gaining complete visibility and control over your distributed tasks, much like a mission control for your background processes. By the end of this lesson, you'll have a solid understanding of how these powerful dashboards are constructed and why they're indispensable. Specifically, you will be able to understand the importance of real-time dashboards in keeping complex systems running smoothly. You'll also learn to identify the core architectural components that make such a system tick. We'll trace the intricate data flow and control mechanisms, giving you insight into how information moves and actions are triggered. Finally, you'll grasp effective strategies for managing distinct UI states and integrating with broader production infrastructure. Let's get started. Imagine driving a car without a dashboard. You wouldn't know your speed, fuel, or engine health. In the world of software, a task management UI dashboard is exactly that, your command center for distributed tasks. It provides real-time visibility into everything happening across your system. This isn't just a nice-to-have, it's fundamental for any production environment. This dashboard serves three critical functions. First, monitoring, knowing what's happening right now, whether tasks are running, pending, or failed. Second, control, the ability to intervene when needed, like retrying a failed task or pausing a queue. And third, analysis, learning from historical patterns to optimize future performance. Without this level of insight, you're effectively flying blind, making it incredibly difficult to diagnose issues or optimize performance at scale. It's truly essential for observability, enabling proactive intervention and informed decisions that keep your applications robust and responsive. Now let's peel back the layers and examine the core architecture that powers such a dashboard. Our design follows a clear separation of concerns. At the top, we have the front-end layer. This is typically built with frameworks like React, responsible for rendering real-time data and handling all user interactions. Crucially, it subscribes to WebSocket connections for live updates, ensuring your view is always current without needing to refresh the page. Next, the API gateway acts as the bridge. It provides RESTful endpoints that connect your front-end requests to various back-end services. This layer also handles vital functions like authentication, rate limiting, and intelligent request routing to maintain system stability and security. Below that is the task service layer. This is where the core business logic resides, managing the entire task lifecycle, handling queue operations, and aggregating metrics. It abstracts away the complexities of distributed task processing. Finally, for data storage, we leverage a dual approach. Redis for its speed in managing real-time metrics and queue states, and PostgreSQL for robustly storing historical task records and audit trails, ensuring data integrity and long-term analysis. Understanding the components is one thing, but seeing how data moves through them is key. Our dashboard's control flow and data movement happen across three primary streams. First, the real-time stream. This is how you get instant updates. Task status changes flow rapidly through a Redis pub sub mechanism, pushing these updates directly to your UI via WebSocket connections. When a task starts, completes, or fails, you see it reflected on your screen almost immediately. Second, we have the control stream. This is for your actions. When you interact with the UI, perhaps clicking Retry Task or Pause Queue, these user actions flow from your React components through the API gateway and into the task service. The task service then updates the queue state and triggers the necessary actions by your worker processes. And finally, the historical stream. Once tasks are completed, their records are written to PostgreSQL. This data then feeds into analytics queries, powering the trend charts and performance reports you see, providing valuable insights over time. This robust flow ensures instant updates for immediate awareness and actionable insights for long-term system improvement. A truly resilient dashboard needs a robust state management strategy. Our UI manages 4 distinct states to ensure a smooth user experience even under pressure. There's the loading state for initial data fetches and establishing WebSocket connections. The active state is when real-time updates are flowing and user interactions are fully enabled. The error state gracefully handles connection failures with built-in retry logic. And finally, the maintenance state allows for controlled degradation or informative messages when backend services are being updated. Each of these state transitions is explicit and recoverable, meaning users never lose context or control, even if parts of the system are temporarily unavailable. This dashboard isn't an isolated tool. It integrates seamlessly with broader infrastructure management. Task metrics feed into alerting systems, performance data influences auto-scaling decisions, and historical patterns inform capacity planning. In a real-world production context, your dashboard will face scenarios like dead letter queues filling up, worker nodes becoming unresponsive, or traffic spikes overwhelming processing capacity. It needs to surface these issues clearly and provide immediate remediation paths. The interface you're building mirrors what site reliability engineers use daily to manage systems processing billions of transactions. We've covered a lot today, building a comprehensive understanding of real-time task management UI dashboards. Pose, we started by exploring why these dashboards are so critical, providing real-time visibility and enabling monitoring, control, and analysis in distributed systems. Then, we dove into the core architectural components, examining the roles of the front-end layer, API gateway, task service layer, and the strategic use of Redis and PostgreSQL for data storage. Following that, we traced the control flow and data movement through the real-time, control, and historical streams, highlighting how information is continuously updated and acted upon. Finally, we discussed robust state management strategies and the importance of integrating these dashboards within a broader production infrastructure, preparing you for real-world challenges. You now have a strong foundation for designing and understanding these essential tools. To solidify your learning, consider this self-assessment question. How would you design a dashboard specifically to monitor the health and performance of worker nodes in a distributed task processing system?